Hello everyone. Today I'm going to show you a demo how an online gaming company can leverage Timeplus to build a real-time machine learning feature processing pipeline. Here is the demo. So first you can see this is the overview of the whole pipelines. So there are several parts. First, we have input sources from like player actions, transactions, and performance metrics. All these are from like online gaming application system recording like what are the player actions and the transactions, how customer user spending, and the performance telemetry data. And this part is actually the the feature processing pipeline. We have a methods view that do the real-time processing and write data to feature streams. And there's a view so we can join all the view together. So this view include all the features. So this view can be used for like training new machine learning model or real-time inference. At the same time, we also show this pipeline, which is we back up all the player actions into S3 as a historical data. So you can use this historical data for backfill. Okay, let's take a look at details of this pipeline. For example, first, this player actions, which contains all the detailed data of player activities like user ID, session ID, what's the event, user event type that the user is playing, and what's the game mode, and what's the details data. So all the stream user can run the query, so we can query this stream uh, so you get all the detailed data in real time. And let's go back to the go back to the data lineage. So and similar like there's a transaction data and performance data. So first, let's take a look at this feature, this 5 minutes feature, which is actually just a tumble window feature. So we run a 5 minutes tumble window and we aggregate, get the total match started and like a total match completed and some other like average kill, mass damage. So this like a online gaming statistic in a 5 minutes window. So this MV will process the stream data, do the aggregation, and write to this feature stream. And so we can query this feature stream. So at this 5 minutes aggregation, so we can run like now minus 10 minutes. We rewind into the 10 minutes ago and get all the features. You can see this is the aggregation result for all the features. Uh, yeah, let's go back to the lineage. So another feature here is that's the previous feature is 5 minutes window feature, and this one is actually we call the cumulative features. That means we run a global aggregation on the player actions. See, we calculate the total game played, the first game played, and last game played. So this aggregation let's keep aggregating all the data from the right at the beginning. So it means it give you the feature for the lifetime of specific users, right? So if you query this stream, you get this cumulative features. Say so for specific user, we get the total game played, the first game he played, and last game he played. And the next one I'm going to show is event-based features. If we take a look at the uh, this query, we actually do a global aggregation, say, hey, aggregate on this transaction data group by user ID. And what we do is actually we use this array sum to get the last 10 game the user played, the 10 transactions in this case, and we run aggregation of the total spending here, like how much money the user spent in the last 10 transactions. Okay, if we take a look at this query, the features, we get this result. This give you the total spending in the last 10 in the 10th transaction for the specific user. For example, this user spent like 335 in last 10 transactions. So this is event time based aggregation. That means every time user spend, there's a new event comes, we actually aggregate it and give you the result. Okay, and last, I'm going to show you the backfill. So here we have a materials view that write data to this player action to the external table. This is the S3 external table. So by doing so, we actually can backfill the historical data back to the stream whenever it is required. So if you query this external table, you actually get all the historical data of this player actions. So, and when required, let's go to show the bookmark here. I have when you so this bookmark give you all the SQL of this feature pipeline I have. And at the last, you can see the backfill is actually super easy. So you just select everything from the external table and insert into the player action stream. And you can, by doing so, you actually backfill the historical data into the stream. So last but not least, I'm going to show you an alert features. So in this case, for example, alert is a new feature in Timeplus 3.0, so new enterprise features. So what we do is actually you can create an alert, specify the batch, limit, and you send the query result to a function. And here this function is actually a Python UDF, so user-defined function. So in this case, we use this Python UDF to send data to Slack. So in this case, we run this query, say, hey, if the total spending in the last 10 transaction is bigger than 750, we will send an alert to the Slack, right? So first, let's take a look. This is the Slack channel I'm going to use for the test. There's nothing. I just say hello to the Slack. We can run this query first. If we run this query, you can see we actually have some it's real-time query, so it give you all the users that spend like more than 750. So let's create this alert. So once I create this alert, it will start sending monitor the data. You can see in the real time we get this alert. The alert send the notification that these users spend uh, over the threshold, and then we can take some actions. For example, user want to give them promotions or do some other user behavior based recommendations. Okay, so a quick summary. All the everything I showed today actually is implemented in this simple query, simple SQL, and this data lineage show you the overall data pipeline. And yeah, thank you for watching this demo.